Good afternoon, members of conference, academic council and guests. I would like to present my research, Models for Cloud System Availability Assessment considering attacks on Content Delivery Network and Machine Learning-Based Parametrization. We represent 3 cities of Ukraine, Kharkiv, Dnipro, and Poltava. Our research investigation is divided into 4 tasks. 1. Introduction. 2. Development the different availability model. 3. Case study, simulation and comparative analysis. 4. Conclusion and future steps. Modern technological developments have increased the need to use web technologies, which, in particular, as a computer paradigm with the appropriate capabilities, greater flexibility and affordability at a low cost. Effective implementation of modern information technologies, web, cloud, IoT, Internet of Things, etc. It is impossible without the corresponding normative documents describing legal norms, problems, risks and ways of their minimization. This work considers an example of the functioning of cloud services for video traffic processing. The CDN is separated from the primary virtual network by the signal socket service and the VPN gateway, as shown on this slide. The cloud architecture model describes a 3-level client-server network architecture that includes 3 networks, mobile, CDN and primary virtual network, 2 service groups of end devices. Application services are hosted on the primary virtual network. CDN also provides protection against these type cyberattacks, but this element is the most accessible for criminal activities. For cloud systems, it is important to consider not only cyberattacks, but also malware and account takeover. In simple models of the availability of the cloud system, such as reliability block diagram or failure tree analysis, various internal and external factors or the dynamics of their changes not be taken into account. On the other hand, the use of a Markov or semi-Markov models should be justified, requiring time and computing resources. Choosing a model and parametrization of input data for the proposed models was performed using machine learning tools. In particular, utilized machine learning operations MLIB based on the use of Spark Big Data Platform were used. The failure of any unreserved element of the cloud system architecture will cause an availability in customer service. Based on this, the reliability block diagram of the cloud system, Figure 1, will include 7 consecutive elements, each of which characterizes the serviceability of the corresponding elements of the architecture. Calculation of the availability of the system with a mixed connection of elements is performed by Formula 1. The graph of states and transitions of the Markov model of the cloud system, Figure 1, includes 1 serviceable state, 4 operational states and 9 inoperable states. The system of Kolmogorov-Chapman differential equations and initial conditions is represented on this slide. Availability function is defined by the formula on the left side. The multifragment model of cloud system availability allows taking into account the change of input parameters in one model step. This complicates the marked digraph of the functioning of the system, as shown in this slide. To simplify the perception of the model, in the graph all transitions not related to the attack on the CDN are hidden in the superstates. The probability of success of the attacker is weighted by the parameter alpha. After several successful attacks, the intensity of the attack reaches its maximum, because for technical reasons, the attacker cannot speed them up. The value of the resulting availability indicator in the multifragment model is determined by formula in this slide. We built and analyzed 3 models, RB, Markov, single fragment, and multifragment. The main assumptions of this models presented in slide 10. The primary input parameters of RB, Markov and multifragment models were determined on the basis of research and certification data for the analog version's key cheese samples. Their values are presented in Table 1. Comparison of RB and Markov models is performed for stable availability. Under this condition, the solution of the Markov model is reduced to a system of linear equations. The results of the calculations are shown in Table 1. The simulation results showed that the difference between the cloud system availability indicators determined by Airbnb and Markov models have differences not exceeding 0,0034. The weakest element in the architecture in the absence of attacks or end-user devices. Estimates obtained using Airbnb and Markov models with increasing CDN failure rate, left figure, increase the discrepancy from 0,0034 to 0,0051. The change in time of the availability indicator, illustrated by the Markov model in right figure, shows the asymptotic direction of the function to a stationary value during the first 200 hours of key's operation. Graphs in left figure allow you to compare the results of Markov and multifragment models. The availability function obtained by the multifragment method reaches a stationary value after 800 hours of operation, and the specified value of stationary availability is A equals 0,9189. Right figure illustrates the influence of the input parameter alpha on the dynamics of changes in the availability function. As the parameter alpha increases, the time of transition of the availability function to stationary mode decreases, so for alpha equals 0,5 t equals 800 hours, for alpha equals 0,9 t equals 400 hours, that is twice as fast. Conclusion, decision making and future steps presented in slide 15. Further research should be directed to the development and research of cloud multiversion architectures by use of DevOps tools. Thank you for your attention. I look forward to questions.